Alright, so we're up to version 3 of the n-queens problem. As I said last time, the program works well for small things, or the old version did, but what happens when you punch in something large? It would hang. It would sit there for a long time thinking, and the GUI would be unresponsive. You couldn't change anything or select anything. You couldn't copy something. So I wanted to make it where it'd work on larger problems. A couple of small things that are obvious. I changed the colors here, made things bold. Since we're dealing with bigger grids, we're not going to blow it up as much. These cells are going to be smaller, so I just found that I needed something that was easier to see. We have the frame rate here. That looks similar to the speed of the triangle. The details are different. The implementation is different. Here, we're just sleeping most of the time. We're going to be doing some real work, and it's just that we want to pause every once in a while to update the screen. So under the hood, it's different, but I did steal this GUI code from the triangles. Well, let's take a look. Again, even a normal chessboard, it's just too quick to notice. But what if we make it twice as big? Well, I almost saw something, I thought, but let's go bigger. Again, if you really look closely, you could kind of see it trying to update something, but let's make it even bigger. There we go. Now you can see it working. And, well, we'll take a closer look, but let's just see this in action real fast. So you see it just updating. It's giving you more details. It's running, it's doing the actual work at about the same speed. It's just a question of how often it updates the screen. It's probably just a little bit slower, all that extra work just to show you. And this slower setting just makes it easier to read if you're trying to actually see what's going on. That's kind of nice. These are disabled while the thing is running. We'll call that a homework assignment for somebody to fix that, so it doesn't. So you can change the speed while it's running. But we'll take a closer look at what's going on. But let's look at the code. Inspect. Okay, sources. Huh. That's interesting. I did most of this while you weren't looking, and of course, as soon as I started recording, it's acting weird. It's only showing me one of my two files. How about, is there a pause somewhere? Well, this is just killing me. Didn't mean to have you stare at this screen with nothing on it. Basically, right up here, so you need two separate files, one for the thread and one for the main program. Let me try refreshing it. There. How crazy is that? I mean, once again, you're seeing the real world. It's just like that. This just wasn't here. You have to do it in the right order. You have to bring up the debugger and then hit refresh, not the other way around. You can't bring up the page and then the debugger. All right, so this is the part that's doing the actual work. This is the part that's actually solving the problem. This one up here is what displays the result and takes in the input. So let's try this again. 32. Just a little background noise while we're looking at this. Remind you of what we're doing. All right, so now, by the way, this separate file means all sorts of things. You notice I'm not showing you the editor where I normally change things on my desktop and then copy them to the web at the end. There's something crazy, the security thing. Basically, Chrome doesn't let you do this. I mean, it requires you to do what we're doing on a website. Again, I'm not going to get into all that. It just seemed easier just to do what was easier for Chrome. Very annoying. And again, these are called web workers. I call them threads because that's what every other programming language calls them. But web workers, if you want to look it up. All right, so here's the real work. First thing we do, here it is. There's a lot of these messages to the console just because this was the first time I'd ever done anything with a thread. And I just wanted to know if I even started it, if I even loaded this file. And by the way, the first time I didn't, but it gave me an error message, so it wasn't terrible. In fact, that's what pointed me to that web page. And well, just another annoyance. All right. Honestly, most of the time I work directly on the server anyway. I just found this editor was a little more convenient for showing off to other people. All right, so the variables. Well, period MS. Here we have the frame rate, and of course, rate and period are the same. This one's reciprocal of the other. So this just says how many milliseconds before the next time we display stuff on the screen. And next report time. That's the whole thing. I'm going to keep running just like normal, but I'm going to keep watching the clock. And every time I get to this time, I'm going to redraw it, and then I'm going to add period MS so I know what the next report time is. Here's how you receive messages. The thread is totally separate from the main program. The thread can't just go out and say, what's this button or something like that. You only send very explicit messages. So when the main program wants to talk to us, it's going to send a message. Again, another thing just to the log file that could be deleted. And what's in there? Well, there's basically 2 bits of data that we're packing in here. We have this period, this how fast do we update, how often do we send stuff to the screen. Then we have this next report time. Well, new date by default comes up with the current time. Date and time are usually merged together on a computer programming in a programming language. So sometimes they call it date or date time or whatever. It's basically this is when do we want to update the screen. And the first time we say now. Let's say you had a big board over here and you wanted to change it to something else. Well, you can't because excuse me. Let's say you had a result and then you hit solve on a new problem. You want it to immediately erase what the old problem was, even if it's nothing interesting, even if it's all just this gray area. You still just want to immediately do that. So that's why I said next update time is now. Okay. So here's the other thing, was the size. This was always an input. You've seen that before, and all we're doing is saving that just locally. We're just opening up, so E data is exactly what got sent from the other thread, and now we've taken the two elements out of there. All right, then we call solve. That's nothing new. We called solve before, and we gave it the size, and we didn't set an initial state. It uses this default empty list to say no moves yet. The set of moves is initially empty, but solve is either going to return false or a list of winning moves. That's when it's done. And then when it's done, we're going to send a message back to the main program. Again, messages are the only way to go in either direction. And it's this object notation that we've used before. I sometimes called it a dictionary or a map. And we're just packing several data items into this message. Size, well, that's exactly what we were given. We just want to remind someone so it'll be easier to draw the board. That's all. Moves. This is the answer. This is put a queen here, and then on the second row put a queen here, and on the third row put a queen here. And done equals true. Notice how I disabled this solve button. When you're single-threaded, you don't have to do that. You basically get that for free. But what would happen if I sent another request while I was still working on this request? Would the two maybe be done on different threads? Would they be interleaved? We'd see the results of one and then the results of the other. Or maybe they'd get queued up. So after this thing ran for 10 minutes, suddenly you'd have 3 others waiting in the queue that would also run for 10 minutes. No, I just wanted to disable that until we get a message saying we're done, and then that'll go back to normal so you can run it again. All right, so report if required. This is how we report stuff while it's running. Similar to what we've been discussing. There's the size. You need to know the size of the board so you can draw it. And moves. This is the list of what we know. It's never going to be false. It's always going to be something. When we fail, we're done. So this final one could be false, but this one's a list of moves. And you notice how sometimes it's shorter than others. That's why we needed to say the size explicitly. In the old code, we just looked at the moves. We said a winning thing will have in moves, and that means in rows and in columns. All right, so we check the current time, record that. We ask, is it time to report? If not, and most of the time it's not, we're missing just tons of moves over here. So if not, we don't do anything. But if it is time to report, well, we send a message very similar to before, but done as false. So it's still going to update the screen the same way, except that the solve button will remain grayed out. Next report time. This is just how you do it in JavaScript. You say, take this time and convert it into a number, which just happens to be in milliseconds. So you take the current time, and you add on some number of milliseconds, and then you convert that back into a time object. Again, date and time are the same. It actually makes sense if you work with it. And then solve. That's the last part of this. This is identical to before with just one change. Every time we start, every time we try to solve, we check if we need to report back to the GUI thread or not. And again, this initial state, it's never going to be false. This is, we're about to start trying to solve. You only get false at the bottom when you can't solve, when you've given up. So this code, I'm not going to go over it in detail. It's exactly what we've seen before. Oh yeah, this little thing before that I'm pretty sure I misspelled, I still hadn't looked it up. I'm going to say that this is pointless, and I'm glad that I just made a note to myself instead of trying to do it. Basically, I've only seen small items small chessboards that don't have a solution. Every big one seems to have a solution, and it seems like there's always a solution where the queue is over here. So what would we have gotten? I've just never seen the case where we got halfway across and we still keep trying. Again, with the small ones, it doesn't matter. There's no need to optimize. Okay, let's take a little break from the code for a second, just a second to, let's just take a closer look at what's going on here. Nothing is where I think it'll be. Zoom. All right, so just take a closer look at this solution. Now notice, I said this before about depth first search, but now it should be very obvious. These top lines never change. We said, what's the first possible thing? Just going left to right, and let's try it. So we put the Q in this first column. Then we went to the second row. These two were blocked out, so we grabbed the first one that was available. Oh, wow, we finished. How about that? And then this third one, same thing. You notice a lot of this type of diagonal, down 1, 2 over, very common. It's just grabbing the first one that's possible. Again, there could be a lot of different solutions, but we're just going to grab the first one, just blindly go from left to right. And let's try a slightly bigger one. Don't want to run out. Solve. And again, you notice the higher up these things are, the less they change. This row is just slowly moving across and trying different things. And every time it gets all the way across, the row above it moves one. That's what the loops are. That's what they're doing. We're trying the stuff at the bottom first, just like the triangle. This 1 is just going to stick around. This 1 is like the top row. This 3 is like the second row. We're diving deep in. Oh, this thing doesn't like the zoom well. That's a whole nother interesting problem. It's low quality. It just doesn't handle the zoom. But yeah, the same thing is happening on all of these rows. Sometimes it's hard to see. The stuff at the bottom, again, it's just updating so fast and you're seeing just little snapshots, so you're missing some of it. But if you just watch, this row just keeps moving quickly. Every time it gets to the end, this one tries the next, and if this fails, then this row will move over by 1. There it is. And it moves very seldom, just like the lower numbers, like this 37 is going to wait a little bit, but eventually we got to it. The big difference between the triangles and the in-queens, the in-queens can stop as soon as it finds a good solution, where this will always go to the end, so the order doesn't matter. Okay. Well, let's take another look at some code. Zoom back to normal. Oh wow, the 31 solved itself much faster. Just having more rows doesn't necessarily mean it takes longer to run. It's a question of how lucky we get, I guess. So I'll leave that running. Again, it's the same thing. It's going to move faster at the bottom and slower at the top. And you notice a lot of times we aren't all the way down. That could be just a snapshot of where we just happened to be when the timer went off. But I suspect that the reason you never see it near the bottom is we just never get that far. We find an error and fail out sooner. Okay, so back to our other source file. This is the one that was pushing on us. A lot of standard stuff. I added a couple of new styles. Well, these, of course, change. The yellow and the blue, I already showed you. But then we have the blank stuff that's shades of gray. All right, main and init. Oh, I just did some of these get element by IDs just so I'd only have to do them once. It doesn't really matter. Display result. So this is similar to what we had. So the last video we said let's display the case of 4x4 and let's display it pretty, just like if the user had hit the solve button. And we added this part here because in the past I was saying that we only did a complete solution. That's the only thing we'd print. And you'd be able to look at this and know it's a 4x4 grid because there were 4 queens. But in the new code, you have to tell it that this is really the end. This isn't just my first attempt at a 100 by 100 grid. Create a new worker. That's again a thread, a web worker, call it what you will. And this is the file that we were just looking at. And then here we're adding the message handler. We're saying, hey, whenever you receive a message from the worker, so remember that was up here. When we say post message in the worker, it arrives here in this unnamed function. What do I do? Well, I check if it's done. If so, I set disabled to false. That's a complicated way of saying I enabled it. And it says disable all. That's the solve button and these radio buttons down here. And either way, I display the result. Again, I'm just digging into that object. That object had 3 fields: size, moves, done. And we pulled them out of here the same way: done, size, moves. Okay, disable all, that's the same thing I just mentioned. So again, you can disable or enable. It's either way. You use the same function. And then the solve button, all you'd say, this is just a property that's built in. Either disabled as true, like it is now, or disabled as false, like it was initially when you could press it. Then here's a list of radio buttons. This is similar to what we did before. This query selector, only I said query selector all. So instead of finding the first one that matched, it find every radio button that's tied together. And then I just iterate over them. It's that same loop thing that we've done over and over. For I equals 0, I is less than the length of the list, I plus plus, and then the same thing. It's just a property disabled. All right, grid cell. I changed this just a little bit from before because we have more colors now. That's all. So you can still do this part, and what we used to call grid cell is now live grid cell. So it's either the black background or the white background. But then I have this empty grid cell, which does the light gray or the dark gray, and it doesn't even ask for an input. We know it's empty. The only reason we're drawing it this way is because we don't know where the Q is going to go. Display result, as I said, the size is now an input. This first part is pretty much the same as it was. We're going over every bit of data that was given to us, however big that array was, the array of solutions. So this is the part that's black and white as opposed to the part that's gray and gray. And again, we call it live grid cell instead of just grid cell, but it's the same idea. Then after that, we start from where the other one left off, and we do this bottom part. And we say from the end of the list, remember, if the list had 5 items in it, they have indexes 0, 1, 2, 3, 4. So we're going to start at index 5 or whatever this says, and then go to the size, the actual size that we're told to do. And again, the same simple logic that I showed before for the background colors, just even or odd, and then we just display that. Incredibly simple. and then on button click. So remember we called disable the false to enable everything. Well, when you click the solve button, now we're saying disable is true. Everything should be disabled, all the controls. Um, yeah, I, I mean, there's alternatives. We could have killed the thread and started another one or something like that. There are so many options. You can see the same thing. This queue is about to move. If we watch it long enough, then that queue will move. Okay. And most important, this is where we post the message. This is where we send the request to the worker thread. And just like we saw in the worker thread, here's where we received it. It grabs period ms and it grabs size, and here's where we send it, size and period ms. Not much more. As I said, this frame rate was mostly copied from the triangles. So that's it. That is the in-queens problem for much larger values. I think that's all I've got to say on the subject, but I guess I can let this run a little bit longer. There it is. This one's moving kind of quickly, and this one's about to move. It won't be long before this one moves. Again, you see these rows that I pointed out before where it's just the minimum amount that it had to move over. It always wants to try the one on the left, and it was an arbitrary decision. It was just let's go left to right. We could have randomly picked the order as long as we kept track and we could backtrack. Yep, there it is. It moved. Presto. Bazinga. Done. Thank you for watching.